trinomials. And as always, I'm going to try to give you my examples over here first, let you kind of start the first one with me, and then as I always say, pause the video, try some of these on your own. If you fail, that's okay, right? You're going to learn more from doing these and making mistakes, and then watching what I do. You're going to learn a lot more doing it in that way versus just watching me do all of these problems, okay? And I tried to give you kind of like an assortment so that you're getting a really good understanding of what exactly needs to be done for these types of problems. Now, I'm hoping that by now you've already watched my video on the FOIL method, multiplying binomials and all that kind of stuff. Let me just quickly go through it just to kind of have something to start with, okay? Let's see here, I'm gonna kind of give myself some space over here just so that I can use the middle for that stuff. But when we have let's see here, two binomials, we have like x plus 3 and x plus 5. Okay, we know we can use the FOIL method and do first x squared outside 5x inside plus 3x. I know I'm going fast, but like you should know how to do this if you're watching my video for this. Plus 15, combine like terms, x squared plus 8x plus 15. Okay, so we've created a trinomial here. And now all we're doing is, remember when you multiply, you get the product? Well, if you bust apart that product, you're gonna end up getting the factors. And that's what we're working towards. Like what two numbers multiply to make a certain number? You could also just say, well, what are the factors of that number? Okay, so we've gone forwards, and now factoring is really just kind of like the backwards method of unfoiling something. Actually, I don't know if that's the right term, so don't quote me on that. But we're gonna work from this guy and try to get back up to this, okay? So let me rewrite this guy a little bit bigger here. X squared plus 3x plus 2. All right, let me just make a little division line there. Okay, the way I like to present this is you got to look at this in two different parts. Now the first part is, well, what are my factors? And if you're not good with factors, that's okay, but you got to get pretty good at like, you know, your math facts from like 2 to 13. You really should be strong with that stuff by now because it's really going to help you when it comes to these. Now, the way I like to present this is what two numbers, when multiplied, make this number, but when added, make this number. Now, yeah, there's a little bit more to it than that, but let's just start with that, okay? What two numbers, when multiplied, make this, but when added, make this? And we gotta make sure we're sticking with whole numbers. We can't do like 2.4 times like who knows what. We gotta stick to actual whole numbers. We can't go crazy, okay? And no fractions either. So the way I like to present it and the way I like to draw it out is I usually just draw like a little arrow like that, and I write my factors on top of each other as like sets of numbers. Now, there's only so many numbers that can make 2, so I'm just gonna write it as 2 and 1. Is there anything else? I guess I'm kind of done, okay? But you know, pretty quickly I can start to see, oh hey, 2 plus 1 is 3, so therefore I think I'm on the right track. And then usually, you know, as we get more factors, I'll usually kind of like circle them like that, so I know which set I'm working with. Then it's just a matter of creating your binomials. We know we're gonna have an x in the front for both because the FOIL method is gonna give us x times x, giving us x squared. Everything is positive in this expression, so I don't have to worry about pluses or minuses or anything just yet. So I can write in a plus and a plus. And then my next step would be to say, okay, well, now I have to plug these into this back area here for both of these. Does it matter if I put the 1 first or the 2 first? No, it doesn't. And the reason it doesn't matter is because you're going to be multiplying this stuff together. So just like over here, you know, I did my outside, inside. What if I did inside then outside? You'd get the same thing. You'd get a plus 3x plus 5x. And so you're going to still get the same like terms. So I'll put the 2 here and the 1 here. Some teachers like you to have the bigger number first. I personally don't care. So that's how it would look. And so what we've done is we've factored this trinomial. Let me leave this one up here because I think I got enough room to work on this next guy over here. Okay, and I'm hoping you're starting to see the pattern. If you are seeing the pattern and you want to jump ahead, pause the video, right? Do some of these on your own and see what you get, and then let's compare our notes. I'm going to try to squeeze the next one right here. Let's see here. X squared minus 5x plus 6. Okay, let's do what we're told to do, right? What two numbers make a 6? Okay. Well, I'm going to draw my little caret thing just because, again, it helps me remind myself that I have two things that I need. I need two factors, two things that I'm going to multiply to create a 6. Well, I know that 6 times 1 makes a 6. I know that 2 times 3 makes a 6. Anything else? No, I guess that's it. Okay. And then as I'm doing that, right, as you get better at this, I guess I should say, you should start looking at that middle factor and already kind of start saying to yourself, oh, okay, what numbers are going to make a 6? But sometimes it's tricky, right? I mean, I can make a 6 and a 1 make a 5, and I can also make a 2 and a 3 make a 5. I could do, well, let's try it, I guess, because this is kind of an interesting situation here. What could I do to make a negative 5 using these first two guys here? Well, I could do 1 minus 5, I'm sorry, 1 minus 6, and that's going to give me a negative 5. And then I also have what if I did a negative 2 minus a 3? Is that going to give me a negative 5? Yeah, it is. Huh. Okay, now I'm kind of stuck, right? Because if I use these with pluses and minuses or positives and negatives, which is allowed, right? I'm trying to make something fit into the middle that's a negative 5. 1 minus 6 is negative 5. Negative 2 minus 3 is negative 5. So what do I do next? Well, let's do it together. Here's what you're going to do. You got to start looking at, okay, I know what's going to make the negative 5 in the back, but what about this guy? Right? You're foiling these problems. And according to this, in order to get the back number, it's the last and the last, which are going to give you this guy here. And the rules of math say, well, first of all, we're multiplying these two things together, right? 5 times 3 to get a 15. But we need a positive 6. Okay? And so that's where you guys start thinking, well, how can I get a positive? Well, I can have a positive and a positive, because a positive times a positive gives me a positive value as an answer. Or, I'm hoping you're starting to see it, you could also do a negative times a negative, because a negative times a negative is positive, right? And so that should be like the next thing you start thinking through. So if you got it before I did that, little walk around talk kind of part, then that's awesome, because you're really starting to see the connections in this stuff. So I can't use positive 1 and negative 6, because a positive times a negative is going to give me a negative 6 in the back section here. But I can probably use those. And we can always check too, right? It's not like we're just throwing in numbers and then saying, like, I hope this really works, okay? We can actually verify our work and see what goes down. Let me fill in the values and go from there. Well, again, it's x's in the front, right? Because it's x squared. Okay. And then I have two values here. Now just remember, if you're dealing with negatives like this guy, like a negative 2, that negative sign has to go with the number. So you need to write it in as negative 2. And the other value also needs to bring along the positive or negative symbol, negative 3. Okay, I think I got it all filled out, but let's just double check before we move on to the next one. And if you're already moving on, then that's awesome, because that means that you're starting to see what needs to be done. Okay, well, let's just FOIL it really quick and make sure. The nice thing about these is you can check your own work. You don't have to turn in the test and go, oh, I don't know if I got them right or not. Okay, but let's square them. Let's see here. First is going to give me an x squared. Outside, let's see here. If I do that and that, I'm going to get a minus 3x. Inside is going to give me a minus 2x. And then last is going to be negative 2, negative 3, which is going to give me a plus 6. If I went too fast, just watch the part of the video again. Combine like terms, and usually in class, I always like to, do a little dot, 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 dot. just to really emphasize, you got to be careful with those negatives, okay? They're going to catch you. You're going to lose points, so be careful. -3 minus 2x, same thing as -3 plus -2 is going to be -5, well, x's. And so it does actually match. X squared minus 5x plus 6. And so we've solved for the correct amount. This was a good problem because it really did make you start to see that there's some extra rules that we got to be careful with when it comes to solving these things, these expressions. Let me erase this. And then while I'm erasing this, I'm hoping you're kind of writing all this stuff down, making sure you're following along. I'm going to leave this up here just for one more minute, just because, I don't know, it might be good to refer back to later. Let's see. Okay, we did this guy, we did this guy. Now let's move on to this guy. Let's see here. X squared minus 2x minus 8. Okay, same thing as always, right? Let's start with our factors first. What makes an 8? 8 and 1, 4 and 2. I guess that's it. All right, and as you're making your factors, you should start looking at this middle number saying, well, I'm going to have to use a sum or difference, right? I'm going to have to add or subtract these things because of the inside part of the FOIL method. So what two numbers are close enough together that can give me a 2? Well, it's probably going to be these. I mean, but you never know, right? And as this back number gets bigger, you're going to have more factors. Like if this was 24, then you got like 12 and 2, 12 and 2, and 24 and 1, and 8 and 3, and 6 and 4. Like you got all kinds of combinations. So that's why I like to write them like this, just so that as I have more factors, I can kind of see which ones are going to line up and give me that middle value. Sometimes you just don't know, and sometimes you really just got to try them all. But we'll talk about that in the future. All right, so let me draw these. And I guess, part of us can just we can just kind of start plugging stuff in and see. We need a -2 in the middle and a -8 in the back. Now, up until now, a positive times a positive gives us a positive, and a negative times a negative, and that last one gave me a positive, but now I need a negative. So I know that one of them's got to be positive and one of them has to be negative, because when I do my foiling, the last part's going to be a positive times a negative to get me a negative. And now I need to start thinking about, well, what about the 4 and the 2? Where are those going to go? Well, you could just do the guess method, which I have students that do that, and they just throw the values in, foil it, and see if they got it right. Or, as you get better, you're going to start being able to look at it and say, okay, I think I know what's going to fit where, because I need a -2. So if I had a +4, if I have a 4 minus a 2, well, that's going to give me a +2. I need a -2. So I need to put the 4 back here and the 2 up here so that when I foil it, x is x, that's x squared. Outside is going to give me a -4x, and the inside is going to give me a +2x, which will, when you combine like terms, is going to give you that not a -4, come on, a -2x in the middle. And I know that 2 times 4 is going to make an 8 because I was the one that made the factors, right? So that's kind of a done deal. And so when it comes to this, just be careful with your factors, but start thinking about which factors are going to give me an 8 in the back and a 2 in the front, at least for this problem. I'm going to erase this one so we have room for this guy, just because things start to get a little bit more complicated as we go. And again, if you're getting the hang of it, then pause this, right? Try these on your own. Start at the top and work your way through these. X squared, minus 7x, minus 18. All right, back to my ways. What makes an 18? 18 and 1, 6 and 3, 9 and 2, 9 and 2, I think that's it. Remember, you're just dealing with whole numbers. You can't go into 2.6 times 14, right? That's not legit. All right, let's go back to this. And let's figure out, okay, well, we have our numbers that when multiplied make an 18, but I need two numbers that are going to give me a 7 somehow. So what two numbers have a difference of 7? Well, let's keep looking. Or maybe they have to be added together to make a 7. These are just too far apart, 18 and 1. 6 and 3, well, if I add them, I get a 9. If I subtract, I'm going to get like a 3 or something. But 9 and 2 are going to give me a 7. Now I need a negative 7, so, well, I don't know. Let's figure it out. Draw your brackets, right? And make these curved, because remember, if you make them straight, then it looks like absolute value, and I'm kind of nitpicky on that kind of stuff. So make them as curved as you can like that. It just, you know, makes your teacher happy. That's my little public service announcement, I guess you could say. Anyways, let's fill in what we know. Well, we know that's an X, and we know that's an X. It's a negative in the back. So it's got to be a plus and a minus, right? Okay. And then I got to decide, well, I need a negative 7. So if you're jumping ahead of me, or if you really caught on to that last one, you're going to notice that I'm going to put the 9 next to the negative sign. Because when I FOIL, I'm going to get a negative 9 times an X and get a negative 9X. And then I'm going to get a positive 2 times an X and get a positive 2X. Negative 9X, and this is going to be a plus 2X, which is going to, when I combine like terms, is going to give me a negative 7X. And like I said, I know the 18 is going to work because I'm the one that picked the numbers that make 18, so that part's just a done deal. And so from here, that's how you should write your answer. As I said before, it doesn't matter what number is in front. Some teachers and books like the positive value to be in the front, but whatever, like when you FOIL it, it's going to work out to the trinomial that you were already given. So get in the habit of practicing going to the factor values, and then why not FOIL it, right? If you have time on a test, I always say FOIL this thing again and just double check your work, because you know it's not that often, and especially in classes like this where you're able to like check every answer before you turn in your test. Let me erase this and let's get into this last one here. Now this one was interesting just because they just added one extra little thing, all right? They added, well, let's see here, x squared minus 3x equals 10. I like this problem because now you're really starting to like see how this stuff works, and it's really starting to kind of show you how Algebra 1 really does pull everything together in a nice, neat package. And a lot of the skills that you're learning are gonna be used later. So problems like this are great introduction problems. Well, or introductory problems, I guess. Well, I can't really factor it like this because, you know, usually it's been like part, right? And now this one has like this guy over here. But can I rearrange the values? Can I move some stuff around? Yes, I can. So let's do that. Let's get everything on one side. And the way I need to move this, remember, to get it to the other side of the equal sign, is I gotta subtract it. Subtract 10, and I always say, you know, what you do to one side, you gotta do to the other. And there's no like term, so it just kind of floats over there, but this is gonna give me now a 0. So let me rewrite it here. X squared minus 3x minus 10 equals 0, and that's okay. You know, I have students that go, oh man, like, is that okay to have zeros over here? Yeah, that's fine, right? It's kind of just like a placeholder if you want to think of it that way. And now I need to do my work. What are my factors that make a 10? 10 and 1, 5 and 2, and I guess that's it. So what two numbers can get me a 3? Well, it looks like these guys are going to be the winners. So let me do this. And if you need to write the equal 0, you can. For me, it's more about understanding how you can manipulate the math problem, move stuff around. That's the key part, right? The fact that you saw that this could be subtracted and moved, that's awesome. And then from there, you know to factor, that's great. So yeah, you technically should have the equal 0 there, but it's not the end of the world. You know, you're gonna do that plenty. If you're doing this now and then you're moving on to more in-depth stuff, you're gonna have to write that later. So if you wanna practice now, go for it. You have my x's. it's a -3 and a -10. So because it's a negative in the back, I know I'm going to have a plus minus situation. And I need a -3 in the back. So once again, I need a bigger negative number. So I'm going to do 5 here and 2 here. Check your work. X, you know the front's going to be what, and you know the back's going to be exactly what you chose, you know, the 10, -10. So let's do the middle, which would be the outside. X times -5, and if it helps you, circle the values, right? Because make sure you bring the negative with you, with it. -5x, and the inside's going to give me a plus 2x, which is going to give me a -3x. So it does actually match, which is nice. Okay. So we've gone through all these problems. Send me questions if you have any, but just understand that this factoring trinomials or quadratics or whatever you want to call it really is just kind of like the backwards version of foiling or multiplying two binomials. Thanks for watching. I'll be seeing you.